I have an audience today. But with that said, we're going to go over today naming with transition metals. Those transition metals, if you'll remember, if we look at the periodic table, they're the gray color right here, and they're the green color right there. Those green under the staircase, those are called heavy metals. They will work the exact same as the transition metals. What we call these is we call these polyvalent electrons, or polyvalent atoms, polyvalent atoms. If we look at it, let's look at chromium, for example. Chromium can, it's right there, chromium can have different oxidation numbers, meaning different charges. Sometimes chromium, I'll draw this on the board, sometimes chromium is going to be 2 plus. Sometimes chromium is 3 plus. Chromium's really weird because it can be as much as 4, 5, 6, 7 plus. That means it can actually gain or lose, in this case, 6, 7, 8 electrons, or 2 and 3 in this case. Okay? So a couple other examples, tin, which is Sn. Tin is always going to be either 2 plus or 4 plus. And it matters which one we're talking about because they actually have different compositions. And they actually have different melting points, they have different boiling points, they have different characteristics about them based on this information right here. Okay, so first thing we're going to do is we're going to work with these and name them based on their oxidation numbers. So, let's look at iron. We'll do iron 2, meaning 2 plus charge, and then we'll also have iron 3. Which is 3 plus charge. You're going to see why I'm calling it iron 2 and iron 3 here in a minute. So, if we look at iron, let's go ahead and put oxygen with it. Oxygen's charge is always going to be 2 negative. We know that. And I'll show you how we know that. Looking at the periodic table, we have oxygen right there with 2 negative. Okay? 0, negative 1, negative 2, negative 3, plus or minus 4, plus 3, plus 2, plus 1. If you need more information about that, please see the video titled Ions, and that will help you out with that. Okay? So when you crisscross this first one, when you crisscross it, you get Fe, and the 2 comes down. So this is Fe2, because the 2 came down, okay? And then this 2 goes on the other side of oxygen. If you remember from, I believe this was the crisscross video, I talked about empirical formulas. Empirical formulas mean the lowest ratio of atoms. If you'll notice, Fe2O2 is 2 irons and 2 oxygens. That obviously can be reduced to 1 iron and 1 oxygen. So empirical formula, lowest ratio of atoms, and ionic compounds, which these are, will always be the lowest ratio of atoms. So instead of 2 to 2 ratio, the way that you should write this is FeO. Okay? And that's just a 1 to 1 ratio instead. Now, let's look at the bottom one, which is where we have iron with a 3 plus charge and O2 negative. When you crisscross that, we get Fe, the 2 came down, O, and the 3 came down. Okay, remember you aren't doing the actual positive and negative charges, you're just doing the numbers. So when you take these down to the bottom, to the subscripts, they will only be the numbers and not the positive or negative charges. So Fe2O3 is a 2 to 3 ratio. Lowest ratio? Yes, it is. I don't know why I asked a question on a video where you can't answer my questions, so sorry about that. So what you notice is iron 3 has this formula. Iron 2 has that formula. Totally different compounds, and that's just based on 1 electron missing when we look at iron. Okay, so transition metals work a little bit different in terms of naming as well. Because when you name these, you need to name these based on which one we're talking about. Okay, if you don't name them and specify, oh, this is iron 2 or iron 3, you could wind up with the wrong chemical, which if you think about all these chemicals and what the uses are, for food, for drugs, anything like that, you don't want to end up with the wrong one. So it's important that you know which is which. So, how do we name it? Let's look at that. FeO. Let's name that. Let's look at the rules real quick. Rule number 1. Okay, I'm going to write it as I wrote actually first spell as well. Cation goes first. And name stays the same. If you can't read that, it says the cation goes first, so that's the positively charged ion, and the name stays the same. So that's just as though we have calcium, calcium stays calcium. Nothing changes. Iron stays iron. Sodium stays sodium. Really nothing's changing there. Okay? Step 2, we're going to skip. And then we're going to write step 3. Just leave a line for step 2. You'll see why here in a second. Step 3 is going to work like yesterday. Step 3 was anion goes second, or third, last, works. So it goes last, and ends in IDE. So the anion goes second and ends in IDE. Okay? It ends in IDE. So, same thing, we have phosphorus, how it ends. You change the ending to IDE, phosphide. Oxygen, you change the ending to oxide, anything like that. So, pretty normal there as well. Last thing is probably the trickiest part, is number 2. In the middle is when you are going to put Roman numerals. So this is naming for transition metals, okay? Because we have iron 2 and iron 3, both of those have different oxidation numbers. We have to put Roman numerals to show really which charge are we talking about. Are we talking about iron 2 or iron 3? Okay? So let's see what this looks at like. This is just naming with transition metals. With transition metals. Okay? Yeah, we'll change around this third rule here in a minute. If need be. So, let's give a couple examples. I'll put the examples down here so you can see the rules while you work with it. Okay? So let's go through, we'll do Cu, and I'll do crisscross first. So let's do Cu plus and S2 minus. So copper, I had to tell you the charge. I had to tell you the charge so that you knew it's copper 1. It might not be copper 1, it's a transition metal. So I had to literally tell you that that copper was copper 1. Okay? The sulfur you knew was 2 negative. When you crisscross, you get Cu2 from the sulfur. So Cu2, and then you get S with a 1. You don't have to put the 1, it could be Cu2S. So this is the formula. That's great, but let's name it. Okay? So rule number 1, cation goes first. That's the positive charge goes first, and the name stays the same. So copper is going to be copper. This is how you name it. Okay? Let's skip rule number 2. Let's move on to rule number 3 real quick. Anions go last and end in IDE. So sulfur was the anion, it's a negatively charged ion, goes last. So sulfur changes to sulfide, it ends in IDE. So we write copper sulfide. Last thing we have to do to name these is we have to put information inside those parentheses. Roman numerals go in the parentheses to show the charges of the cation. It shows the charge of the cation. Do not put the charge of the anion. Okay? So what this means is the charge of, right here, the cation is positive 1. So you put Roman numeral 1 right there. So it would be copper 1 sulfide. Okay, that's how you would name this compound right here. Okay, let me show you real quick before we start naming a few more. Let me show you all the Roman numerals so you can look back and say, hey, I know all the Roman numerals. Okay? So these will be in order. That's 1, 2, 3, and 4. And that's 5, 6, 7, and 8. Those are the only 8 that you need to know, but you do need to know them. Make sure you can draw all those Roman numerals. Okay? Let's go ahead and name a couple more. Just to give you practice, we're going to use the same rules. Look at your papers. Make sure you know those rules. So let's name, let's pick 10. SN, and we'll pick 2 plus. What other element should we pick? Phosphorus? Let's pick phosphorus. Okay? The charge of phosphorus, as you know, look at your periodic table, it's 3 minus. So when you crisscross, you get SN3, P, the 2 goes down, P2. So let's name this. Sn on your periodic table is 10. And it's not 10(3). Okay? It doesn't, when we put those parentheses, we aren't writing the number of atoms, we're writing the charge. So the charge of 10 is 2. So we would name it 10(2) phosphide. 10(2) phosphide. Okay? If we look at another example, let's go ahead and do 10(4), which is cool to say. SN4 plus. You crisscross again, you are going to end up with SN, the 3 comes down, P4. SN3, P4. To name it, same way. It's going to be 10 phosphide because this is 10, this is phosphide. But in the parentheses are going to go the charge of the cation. The charge of 10 is 4 plus, so I put a 4 there. Okay, so it's 10(4) phosphide. Okay? So that's it for naming transition metals. I am going to do a quick segment on uncrisscrossing. How do you find out the charge of these transition metals that you guys need to look at here in a minute. But this is generally how you name it. So we'll add a segment here in a minute.